Alright, welcome back to another video. This is 2.4 Rational Equations. My name is Mr. Martin. I'm going to walk you through it. Alright, we are going to talk about how to interpret equations that have let's do that in a different color, that have a variable in the denominator. So we know that we can never ever divide by 0. So we're going to actually set some of these restrictions like 1 over x where x cannot equal 0. And we're going to figure out what the actual value is for x. And we're going to do this by joining them with a AND statement so we can find the actual solution set and these restrictions. Alright, let's go ahead and jump into our things to know section. We already talked about it a little bit, but a rational equation is where the variable can be found in the denominator of any term. So it doesn't have to be all of them, it could just be one of those. And these are special, very, very special, because you got to check to see what numbers won't work. Okay, and this is what we talk about, the zero product property. We know that if we have two factors and either one of them are 0 or both of them are 0, we're going to get 0. Okay, so this is going to be kind of useful to kick around in your head from time to time. Alright, let's jump into our first example. Okay, we have this 8 over x is equal to 4 over 5, and down below it is asking what number would not be a solution to this equation and why. Well, we know we have an x in the denominator, and if x were 0, right, then we would not be able to do anything here. We would have something that we call undefined. So we cannot assign a value of 0 for our x, so we simply state that by saying x cannot equal 0, and the y is we can't divide by 0. Okay, oops, there we go. Alright, so if we can't divide by 0, we can still have a value here, and the way that we find this out is we do what we call the cross multiply. When you have a fraction equal to a fraction, you multiply diagonally across. So here we're going to do this 5 times 8. And then we set it equal to our other set of multiplication, right? This is like our proportions that we've solved back in the day. So we got 4 times x. So on our left we got 40. This is equal to 4x. We divide both sides by our coefficient and we get 10 is equal to x. So our solution here is x cannot equal 0. That's one of them. And another solution is x is equal to 10. Okay, so this is how we are going to be solving these rational equations. We first need to find out what would make a 0 in the denominator, and then what value can we actually place to get two equal expressions. Alright, let's take a look at example number 2. What number would not be a solution to this equation and why? We have this variable in the denominator. This time it's a little different because we have two terms, okay? So we can't just say 0, right? If we put a 0, we would get 0 minus 8, and we'd actually have a non-zero number. So we first need to figure out what would make this expression in the denominator equal 0. What value can we plug in that would give us 0? Okay, and we do that by setting the expression equal to 0 and then solving for x. So here we got a negative 8. The opposite would be plus 8, and we then get x is equal to 8. So this is not solving for x. This is just solving for that denominator to see what value it would make 0. Okay, so we know that if x is equal to 8, if we plugged the 8 in there, we would get 8 minus 8, and that would equal 0. So we cannot use the number 8. That has to be part of our solution. Okay, now let's go ahead and actually solve. Remember, this is a group. So if you multiply one factor to another factor that is a group, you must put that set of parentheses. So we have 2 times the group of x minus 8 is equal to 3 times 12. So we got 3 times 12. And you guys know how to solve this. We distribute first, right? So we get 2x minus 16 is equal to 36. and then we add the 16 to both sides, and we get 2x is equal to 52. I think that's 52, 36, 46, 52. And then we divide both sides by 2 for a value of 26. So we know that 26 would make a set of equivalent expressions. So we know that x can equal 26 and it cannot equal 8. So we need to find the restriction and we need to find the solution. All right, let's take a look at example number 3. Okay, this one is just a little bit different in the fact that we have a two-term variable term in the denominator on both sides. Okay, so here we're going to find more than one restriction. We're going to have a restriction here and right here. So we do that by setting these equal to 0. So we get x minus 3 equals 0, and we also have x minus 9 equals 0. And then we want to solve for these. So we got plus 3 plus 3. So if x is equal to 3 over here, we would get a 0. And adding 9 to both sides here, if we have x is equal to 9 over here, we would get a 0. Okay, so these are two of our restrictions. We can put those down here. So x cannot equal 3. We can use the and symbol. And x cannot equal 9. But now we want to see if it can equal something else. Alright, so let's multiply these across. We got 6 times x minus 9. And then we also have 3 times x minus 3. So we just distribute out. We get 6x minus 54. And we also get 3x minus 9. Alright, I want to get rid of this 3x over here, so I subtract 3x from both sides. I get 3x minus 54 equals negative 9. I'm going to add this 54 to both sides. Oops. There we go. And then I get 3x is equal to positive 45. Divide them by 3, and we get x is equal to 15. Alright, so if 15 is the value we plug in, we get an equal set of expressions. So that is our solution. But we also have these restrictions as part of our solution also. X cannot equal 3 and x cannot equal 9. Alright, very good. I want you to pause the video here, try the next one, come back and see what you got. Alright, welcome back. Let's take a look at what you got compared to what I got. I set my denominator equal to 0 and found out that if x equals 3 halves, I will get 0, so I stated that as my exclusion down here. I did my cross multiply. Remember, if you have a whole number, it still is a fraction. You can put it over 1, so that's how I got this 35 times 1 for 35. Multiplied the other side, 5 times 2x minus 3. Solved it up, and I found out that x equals 5 would make a set of equivalent expressions. So that is my solution right there. Alright, I hope you got that one. Let's try the next one. I want you to pause the video again and try number 5 on your own, and then we're going to work through number 6 together. Alright, so pause it right now. Alright, great job on pausing there and actually trying it. I totally believe you did it. And I believe you got it right. This one wasn't so bad. Hopefully you set your denominator equal to 0. If you did and then solved for x, you should get negative 3. So negative 3 will not work. We cannot use it. And we notate that down here. After we do our cross multiply and a little bit of number crunching, we get x is equal to 3. So x can equal 3. It just cannot equal negative 3. Alright, if we look at example number 6, this one is a special case. Okay, and you're going to see why here in just a moment. First thing we want to do is we know both of our denominators are the same, so we don't need to set both of them equal to 0. We can just do it one time, and we would get x equals negative 2. Okay, so we know that right now we're not going to use negative 2. That's going to give us a 0. let's go ahead and try to solve this. Okay, so we're going to have 2 times x plus 2, and we're going to set that equal to 4 times x plus 2. All right, let's distribute out. We get 2 times x plus 2 times 2, which is 4, and then we get 4x plus 8. Let's go ahead and subtract this 2x from both sides. We're going to get 4 is equal to positive 2x plus 8. We subtract the 8 from both sides. We get negative 4 equals 2x. Divide by 2. And we get negative 2 equals x. Alright, this is where we're in a conundrum. I just said up here, right, x cannot equal negative 2. Okay, this was that piece right there. We can put that if we want. That is what happens in our denominators. We know that if we have negative 2 plus 2, we're going to get that 0. But what happened when we solved it? We also got negative 2 as part of our solution. So if we have a restriction of negative 2 and one of our solutions is negative 2, this would actually be a no solution, okay? Because we just stated we cannot use negative 2. So that makes this no solution for us. And you can either write it out or do the empty set. All right, let's take a look at our next examples. Okay? I want you to pause the video right here and try number 7 and number 8 on your own, and then come back. Let's see what you got. Man, I can't talk today. All right, thanks for pausing the video and trying. We are back. Example number 7, I set my denominator equal to 0 and found out that x cannot equal negative 2. Put that down here, and then when I did my cross multiply, I ended up with x equals 0. So that is my solution set right there. Okay, example number 8. I'm pretty sure most of you guys said, hey, this thing is equal to itself. It's going to be all real numbers, right? We've seen that before. I went ahead and did the cross multiply just so you could see. Variable disappeared. We got a true statement. So that is true. We can use any real number. However, we have a restriction on this number negative 9. Okay, if we were to plug a negative 9 in here, we would end up getting that 0, which we cannot divide by. So our solution is we can use any number in the world except for negative 9. That is the only one we cannot use. All right, well, I hope you enjoyed this lesson. I think this one's not too bad. Just takes a little bit of practice and a few extra steps from solving equations like we've done before. Thank you for watching. I appreciate it. Remember, if you have any questions, please don't hesitate to ask. Ask a family member, a friend, a teacher. We're all there to help. I enjoyed it. Peace out.